Good morning, ladies and gentlemen. Decided to start the morning with some talk about guidelines, um, simple guidelines to avoid building collapse during and after construction. Yeah, it's about buildings, the collapse. Buildings and the collapse, construction and collapse. In the picture you see we have here we have twin construction. I think this is where we normally build walls. After building walls, leave some gaps, and then later on you put your column. So it's more or less like it is an unreinforced walls made of blocks or bricks. So these columns, I think they help to take on some tensions and the rest, but also it means our blocks or bricks do take a lot. So you have to be careful that we carefully select or manufacture blocks that have specific minimum strength in accordance with the design. So what needs to be done is the engineer will have to, if you decide to construct the walls first and then columns later, which columns do not have proper shapes, we need to calculate and understand the strength characteristics of the block and bricks, and also we need to understand the mortar joint filling that you are going to use also should be understood, because there is a correlation between the blocks and then the mortar. So it is very important that the things are, and then they should be well specified. Very important. So this construction is very good. It saves time and then moves a bit slightly faster. Of course, now all the beams are bearing directly on the wall. So when you are modeling this kind of structure, there's a lot to use on points, spring constants and the rest of it to simulate those bearing conditions. But what I'm trying to look at is why the collapse. There are some guidelines that can help us. So basically that is our driving factor, but it's important to know. Normally we have these two. Then the lower one here is frame construction, where you do your columns, then you do the beams, and then the slabs, then even the scaffolds are done. So this one is frame construction, and but normally we normally confuse these two construction during implementation, in that you design as frame, but during construction those guys start doing this. So you find that these columns do not perform exactly the way it is. These columns are not taking the actual loads as it was designed for. But at the end of it all, it means your walls are load-bearing walls, so that their foundations must also be adequate. You have to have better design for these foundations, and so that you avoid overstressing and creating cracks. Because these joints here, if you look at it, the joints are not well and properly practical on site. So these are the two main construction approach on site normally for adopt. Yep. So point now is the simple guideline why. So this I call it version 1 because we shall be sharing as we proceed, and then to ensure that our young people on site, those who are having access, we are not all the same. There are those who have access to sites and they are doing very good work, but sometimes they lack guidance. So maybe in future, maybe with proper collaboration, I think some of these simple guides should be available to all the construction sites, so that we don't blame people and people don't blame us, the technocrats around. Because sometimes when the buildings collapse, they begin saying the engineers are there, they're not helping, and yet you can also what? You cannot just go to somebody's site and then start saying, hey, introduce yourself. Say, no, that will be trespass. So the background here is Uganda has experienced several building collapses, particularly in Kampala and Jinja, due to what they say out of findings that poor construction quality, weak foundations, unauthorized modifications, and improper material use. Let's get these things clear. Poor construction quality. Then there is weak foundations. Then we have unauthorized modifications. And also we have improper material use. Studies have shown that failures occur when buildings exceed permitted floors. Weak foundations, poor quality materials like cement. Cement also expire. So when they talk of what that would mean it is expired or something, or it is got in contact with some contaminants, and that definitely get affected. Reinforcement bars, some bars can actually get cracks, others get corroded, rusts before, and sometimes they say, oh, this rust is okay, the first layer of rust, but you don't know where it is, the first layer, second layer, or third layer, depending on how. And then also poor quality. So but how do you go about it? I think this is now where they do a bit of quality control testings, and without having testing certificates, or even you attend some of the testing, then inadequate supervision leads to construction errors. Definitely. I like building exceed permitted floors. There is a building in Kampala over Kisu. Construction reached about, I think, 6th floor or 4th, and it seems something went wrong, and they began jacketing, increasing the size of column, and they're saying it looked like the design was for maybe on a 3 floor or 2 floors, and I think the employer or the client added 2 more. Definitely now that will definitely lead to overloading of the lower supports column. So that's not very good. Poor quality materials, basically, you have to be careful, because if you're talking about aggregates, we have uncrushed aggregate and machine crushed aggregate. Normally with machine crushed aggregate, I think quality control is a bit done, because it's done by well-established quarries, and they also check, they do all these other prior tests like sieve analysis, aggregate crushing values and other things. So by the time they dispatch these aggregates for use, their qualities have been checked and they're okay. But the uncrushed, sometimes the qualities are not checked. So if you're not careful, you end up and also even when you store these materials, how do you ensure that they are not contaminated? So there are many factors that do affect. So it is important that at least some of the things are looked at. So these are some of the observations, and they're saying to prevent such disasters, builders must adhere to proper engineering practices as outlined below. So below here we have some of the highlights that need to be looked at. Now, before even I go to the highlight, when they talk of weak foundations, causes settlement and structural instability. Now here, weak foundation, there are 2 things. Weak foundation can be out of poor design, arising from poor design. The sizings and the reinforcements could be an error from design. But also during construction, you may find the excavation did not reach firm ground. And if it doesn't reach firm ground and you're still on the weak soil, then definitely as weight continue, definitely you're going to experience some excessive settlement, which will definitely affect the stability. So during construction, even when they're doing excavation of the site, the supervisors should attend to that to ensure that where those people are, because normally they do it manually. So where sometimes we indicate that foundation depth is determined and concluded from site. It means that the conclusion must be done in the presence of the engineer. When you excavate, you find different layers of soil, and then you reach maybe the brown type or whatever color is, which is now uniform. So you can now say, okay, at this point maybe you go at least maybe 2 feet or 3 feet, depending on the height of the building. But at least you know, as for the siting of the foundation, you are on firm ground. So that layer understanding of the excavation is very important. If you don't understand that, sometimes even these senior people who are on site, those experienced workers, they understand how to estimate practically on site that this is actually farm area. I'm told sometimes you also try to drive pegs. If you try to drive pegs and it's very hard for you to drive it using a sledgehammer, then you know fairly now you are in a farm area, and so you can comfortably found your foundation there. So adhering to engineering practices is very, very important. And what guides here is to at least get qualified people who understand what needs to be done, the processes, and then quality assurance and quality controls. Now, understanding site conditions and terrain awareness is very important. I've just explained when you are siting and putting the foundation, laying your foundation, you need to really understand. Sometimes you have a slopy ground. Sometimes you have an area where it used to be a dumping pit, and you find over time there was dumping, and then you have different layers, and you may find the farm ground is actually 1 or 2 meters below the surface where you are. That is why it necessitates at times excavators to go and remove that thing until you reach some point. But in most cases, developers prefer manual stuff. So with manual excavation, then that's now where some experience also is very important, or use of DCP testing and site investigation, where you do drilling to ascertain that farm ground. So understand it. So most of these buildings they are also site specific. A building in a swampy area will never have the same foundation with that on a hilly area, and that in a flat area and a rocky area. So you have to be mindful of that. So I think you have to assess the ground before construction. That is why it is important investors should engage the geotechnical team. They don't charge you too much, by the way. They ask for very little money. So once you can have that prior investigation, you will understand, especially the depth of the ground or the soil upon which you are supposed to put the buildings. Once the building is set and excavation done and the construction commences, it is very difficult to begin thinking your foundation. You have to now proceed and go up. So you have to assess the ground before that, understand. For the slopy ground, I've told you have to understand that you may end up using some basements, some basement walls, and also retaining. And you should also be mindful of drainage systems. So that is why it is important that the different experts need to at least have some prior visit to the site. Also, the site planning should be done by those experts before engaging most of these staff or the skill levels to build your frame or the house. The level ground, that's okay. You have to ensure proper grading to avoid water accumulation, but of course now that is basically some landscaping coming in, and also thinking about water management at the site, because if you don't have a proper water management, definitely you're going to have a challenge. So for your facilities to have good conditions, environment, Normally, water management, sanitation are supposed to be well thought through. You also need to perform soil tests to determine ground stability. But I think understanding of site conditions for most developers, leave it to the experts. Let them do that. Even those who get the jobs, you can be a contractor. Now, when you're a contractor and you don't have, it's always good for managing risks. You try to share the risks. So here you get your geotechnical people, get your landscape experts, and then the site engineer, those with the knowledge of soil stability, slope stability. They will do for you the thinking, and the rest now will be your money and the workers. Setting out and structural alignment. Now, for most of these frames, sometimes you find that these frames, there are two alignments that are key and which require monitoring throughout until you hand over the site. That is the vertical alignment and also the horizontal alignment. The beams, the slabs, the floor slabs, they should really be truly level, because it has to simulate it has to simulate the model and also the design. So in your model, you are designing as a level floor, but during construction, if you don't maintain and you allow some slope, then definitely you're also going to create some eccentric loads behavior on your columns, and that is how the cumulative effect, if the flow exceeds about 4 or 5 or 6 levels, you're going to find that when you're trying to build and plumb your walls, block walls at the upper floors, they will not be, you see them falling down, because there's already the building is out of plumb. So every level you achieve, you need to make sure you control these vertical levels and also the horizontal level. Horizontal level, you can use your water level at the minimum, because not every site can have those sophisticated survey equipment like the total station and the rest. So I think over the years people have been using water levels, which is very, very good. Then you have the use of plumb bobs for vertical alignment, especially for small scale construction. Yep, it is very important that your foremen and those who are doing carpentry work, because these columns are always plumbed by the are put in place by the before concrete works. They are aligned and molded by carpenters. The molds are put by the carpenters, so they should properly do very good alignment, especially in the vertical direction. Then horizontally, the levels, that one also is okay. That one, so you can use water level. Then every time you do your setting, you must verify the dimensions before proceeding to now do the casting. So that is why now you need site supervision to be stepped up, and then these other tradesmen, the carpenters, the steel vendors, they will do their work. Even concrete normally is the last activity. Once the setting out is done, carpentry work is done, reinforcement done, checking is done, and then the guys of concrete, they come. Once concrete is cast, I'm telling you, when they strike off the column or remove column, you have to see now the beauty of your concrete. If it is not plumbed, then it becomes visible now out, and also very risky for use. So you have to be careful and close monitoring by so your site, our site, must have close monitoring, especially when you're doing concrete frame. When these concrete frames are out of plumb, then they become risky to the inhabitants. Those who are going to use the house or the building will definitely be at a risk. And then the use of surveying instruments at total station, leveling machines to mark the foundation and frame. I think for most developed sites that are built, funded by government, public buildings, normally I think most of these companies do have good equipment. But for the private investors, individual builders, normally that's why you need to make use of these plumb bobs, to make use of water levels. They are approved. some good outputs, and many buildings in town. Yeah, I think they have most contractors have used plumb bobs and levels, water levels, and they've turned out to be in good shape. So these are some of the equipment we need for setting out and controlling alignment. Control of alignment is from the start of construction until almost site handover. Is a continuous activities. So you have to have some, like a surveyor kind of, someone who understands construction survey, levelings, managing staff, invert levels, and all that. So should be positioned on site from the start until the site is handed over. Because you still need the surveyor to work with the landscape engineer to handle also your what they call external drainage, because you need to locate those inspection chambers, the manholes, the septic tank, all those facilities do require level checks and setting out. So we need to have all those guys in place. Excavation and foundation construction. Once you are done with setting out, then you move to excavation now. Of course, you have to be mindful that you are setting out facilities or those profile boats and which they use for setting out, especially for simple frames. They need to remain in position, because every time something happens, you have to cross-check the dimensions, and therefore those benchmarks, the temporary benchmarks, and then other marking that have been transferred to the profile boats, so it should remain. Or if you can transfer them slightly further than, but can easily be referenced out of the construction area, then it is also possible. Because how do you hand over the site if you don't know that it is the alignments are and have not been controlled? So it is very important that we maintain these setting out facilities and the reference point. So excavation, normally you see they are telling to excavate to farm soil. I already explained to prevent settlement, and I told you that most of these project sites, if you are building a site here in Nakawa, and then you go to Mbuya, you go to Kisenyi, you go to Gulu, you go to Kisoro, you are not going to have the same site condition. They will all be different. And so most of these projects are site specific, and therefore the site knowledge, site condition knowledge is very, very key. So even when they're excavating, that farm soil will vary in depth depending on the area and the locality. So it is very important that before we plan to start doing anything, we must understand where are we placing our foundations. Do we have farm ground reachable, or you have to go deeper? Maybe it may require, instead of split footing, you may end up going to use piling. So it is important here. Compaction and use of reinforced concrete footing. Of course, this is an output of design, so the builder will have to make reference to the levels, to the geotechnical investigations, so that now it controls the excavation level. You don't need again to over excavate, because it may prove to be expensive for the client. So you have to excavate to the right depth, firm, good for stability purpose, and avoid over settlement or excessive settlement. Ensure proper footing placement based on the terrain assessment. Definitely, we've already talked about it, and that is why we need you need to have the surveyor, you need to have the geotechnical person, you need to have the engineer. Even sometimes an architect needs to come in, because if you are going to construct already a model house, definitely if the site condition dictates bit of revision, then the architect need to be available to see. Yeah, so excavation must be done, but make sure you have access to the farm location so that your foundations are safe. In terms of material selection and storage, definitely as a client or a contractor, it's difficult. Always, that's why you have to employ the likes of materials engineers to guide on material selection, quality, and also how to store this material. So use of high quality concrete, reinforcement bars, and bricks are very important. But definitely this is just English word. High quality, or you just need to have materials that are fit for purpose. So normally these are dictated by designers. You find a design report has reference to concrete grade, reinforcement, strength used, and then I told you for bricks, sometimes the minimum strength of bricks is also indicated. Mortar type, mortar strength, all indicated. I've told you if you are dealing with twin construction where you are building blocks first, the walls, and then later on you cast your concrete. That means you are almost 80% of your block walling actually is load carrying out wall. It is a load bearing wall, so you have to be a bit mindful. That means the mortar you use and the brick, the strength are all indicated and all reference to the load effect. Yep, so that is important. You have to ensure proper material storage. You see, like for cement, they tell you to keep dry and covered. Should be like in containers. Even the way you, and I told you, I think if you go to those cement manufacturers, they will always guide you that when cell cement is delivered, or cement bags are delivered, you need to use those cement as quickly as possible. And then always, if you are storing cement, you always, there's what they say, that the first batch that you bring in should be the first batch to also use. So if you are storing cement like 100 bags today, you deliver 20 bags tomorrow, another 20 bags, and in the store you want to start. That means when you are commencing work, you start with the first one which you are delivered, because so you have to be mindful of the expiry. And I think they have some period before which you should have used cement. So that is very important. That's why up here they were talking of poor quality cement. So expired cement also are there in the market. So you have to be mindful of that. Steel reinforcement, normally you have to protect from rust. They must be stored above ground, and also if possible under the shade. And then we have to take care of this. Very, very important. I know sometimes people do argue that when the first layer of rust is okay, but I think when they say rust is the initiation of corrosion, then definitely we have to avoid. It's sometimes very difficult to. We have not done much research to know how rust react with other materials component when you mix your concrete and you have reinforcement in. So at the end of it all, we need to be just to make sure these reinforcements are free from rust. They should not be cracked. They should be straight, so that when you're cutting and bending, you don't have any kinks. So that is important. So protect it not only from rust but also from cracking and other things, even from excessive heat. Like you don't need to put any fireplace near your reinforcement bars, so that you maintain the factory condition. Aggregates prevent contamination with debris. Also try to, normally for good aggregate, they always talk of what they call chipping bays. These bays have compartments. They have concrete bases, and then because some of these aggregates come in like size maybe 8 to 10, maybe 10 to 12, maybe 12 to 14. So you try to put them in different bays. So during the batching or mixing, that's when now you can get different portions from different bays or compartments. Then you put them together for mixing concrete. So it is important that avoid, if you store your aggregate directly on ground, then it is important that when they are using, you try to leave at least about 300 millimeter, 1 foot, 1 feet, leave 1 feet unused. That one now will try to buffer the contaminants and then the aggregates you are using. But if you are using it up to the scooping the soil, then definitely your concrete will be contaminated and therefore will not have durable concrete, and the durability of structure will be affected. Mixing, laying, and compacting concrete. You have to follow standard mix ratios of 1:4 for structural concrete. There's also 1:36. There's also 1:1 something. But normally it is important that mix designs are done or carried out by the materials engineer, so that you you are able to control, because you need to know the amount of water you will be using all the time. You need also to know the batching tools, the boxes, the batch boxes. When they say 1:4 in many sites, people relate the ratios to wheelbarrows. They don't know that here the reference is made to an equivalent size of cement. Like if cement is about 0.036 cubic meters or 50 bucks, what we are saying here is that you also get an equivalent dimension which can accommodate that 1 bag. That is what you use. So if I talked of 1 to 2 to 4, if it is a wheelbarrow, then that wheelbarrow must be the same size with the 1 bag of cement. But if you get a wheelbarrow which is as big as twice the cement bag, then definitely you will not have the mix. If you talk of a class 20, and maybe 1:4 is giving you class 20, definitely now what you are achieving is not class 20, could be class 15, because the mold you are using is twice the volume of cement that is required to achieve that 1:4. So normally on site we have that challenge, and this is now something that most builders need to be aware of. Even you as the client or the developer, at least you need to be aware that we don't just. But also of recent, I think they have started making wheelbarrows which can accommodate a bag and a half or 2 bags. So once you understand the volume of that or the size, then you relate it using the ratios, then you do some mathematics, and you're able to also achieve what is required. Not just a matter of mixing it and then pouring sand and then bringing aggregates and then you mix. You will not get the right thing. It's only good for mass concrete and then for ground flow, not suspended flow, which requires some structural competence. Then the use of mechanical mixers for uniform consistency. Yeah, we have these small to medium tilting drums, concrete mixers on site, which I think that is okay. I've seen many sites do have. If we continue with that, I think that is okay. All we need now is how do we mix? What is this 2 and 4? 1 to 2 to 4, are they wheelbarrows or they are batch boxes? So we need to be careful. If they are batch boxes, they should be of the size of the cement bag. If they are wheelbarrows, you also need to make sure they are related to the bag of cement, and you do some mathematics and you calculate. So instead of maybe putting 1 bag of cement, maybe now you put maybe 1.5, then you maintain your wheelbarrows 2 and 4 for sand and aggregate. In that way, maybe you have done that mathematics, and then you do that sort of it. You need to make sure you maintain the batch boxes, which sizes you need to match the volume with the volume of cement bag. Compacting concrete. You have to compact in concrete, of course. They do this poker vibrators to eliminate air pockets, but also for compaction has got its own merits. its own process. You need to be mindful. The size of poker vibrators, but of course vibrators are many. But for simple sites and then for buildings, normally I've seen what is in common use is the poker vibrators. But also if it is rigid pavements and some areas, I think Chinese have developed some other compaction equipment and tools that they use, which like industrial floors and the rest of it. So for poker vibrators, I've seen they're commonly used in bridges, buildings. Basically, those are the two areas I've noticed. The timing, the handling of the poker vibrator, they are very, very important. So we need to be mindful when we are dealing with that. Over vibration can also cause what they call bleeding, and once you have concrete bleeding, then at the end of it all, when you are trying to remove formwork, you're going to see that there's a lot of honeycombing. So some of these site staff should have some minimum concrete technology knowledge, how to do batching, how to do mixing, transporting, placing, even curing. So it is very important. So that is in terms of mixing, laying, and compacting concrete. Now laying blocks and bricks. Here we are trying to look at, I've talked about, you can do bricks and blocks as infill, or they can be like load bearing. But key to these are two things: the strength and the mortar joints. So those two parameters should always be defined by the designer, and it requires a compliance on site by the builders if we are to avoid collapse of building. This is very important. Don't just go and say that I'm using mortar 1 to 4, 1 to 5. No, it is important that you relate your mortar requirement and concrete size and strength to the load effect. The applied loads do have effect on the mortar, therefore it has to be designed for. We have to be mindful of that. I think if you look at, there are some building technology books. I think there's construction technology by Sile. I think it has different concrete blocks relating to the mortar to be used. And then when you're also using Procon for your design, and there is also very good, it also has requirement, there are areas provision for you to choose from different values relating to the loads and also the wall thicknesses. So it is important that we don't just specify mortar just because you want to, or you've done it somewhere. It has to be related. Otherwise, you're going to experience cracks on the walls and the mortar joints, and therefore will definitely get into trouble. And you have seen with the twin construction, all your walls are really load-bearing walls. So if the mortar joints and the concrete blocks are not well designed, then they will definitely have a bit of problems to withstand the loads, and you will see cracks appearing, and then you begin wondering what is causing problem to the building. You have to ensure proper bonding between the bricks using a correct mortar mix. This is what I'm telling you. This correct mortar mix is a design output from the engineer, and it should be part of the specification in the drawing and also in the bills of quantities. You have to keep walls straight and leveled using mason's lines. I talked of vertical and horizontal alignment control. is very important. I think use of plumb box, most builders use plumb box for constructing block walls and bricks, so, or masonry walls. So it is very important that we do that. And also that is vertical, but also horizontal. I've seen them also using a bit of spirit level and also water level. So if you can control both horizontal and vertical, then you should be able to come up with something that is fit for purpose and will not collapse suddenly. Curing masonry work to prevent cracking. Definitely, you have. I think in most cases people they cure blocks only when they've just manufactured. Once they deliver them on site, in many cases, I think there is that reluctance there. We need to also cure to ensure that the density is okay, and yeah, I think it is important that like this put here, curing is important. I know we do much on concrete. When we are done with concrete work, then we do curing 7 days, 14 days, but also we need to do the same for these block walls we do. Now they're saying if you don't cure well, it can crack actually, because we expect reactions, the heat of vibration from this cement and mortar to continue for some time, and so curing will try to control, and you have better blocks which will be adequate to withstand the weight of the floors above. Now, use of water levels for beams and slab. The water levels is a transparent hose pipe filled with water. It helps with coming up with very good levels. So water levels ensures perfect leveling, but also they need to know how to use it. By the way, filling water in that pipe alone without understanding, you have to make sure that you don't have bubbles. And also when you are using, you make sure you read properly. You also have to read it not from top. It has to be, you must look at that, what they used to tell us in physics, the meniscus. You know, you don't just read from up, you check and make sure you get it right and mark it properly. And then, yep, you will definitely, and there is always a data. Someone has to first mark a point. Then the other end now is what is used to control. You now control the other side. So use of water levels has some technique. You don't just pour water and then say, yeah. If water pipe has a lot of bubble, you will get the level wrong. So you also have to be aware of that. So this approach is this cost-effective method helps to maintain structural alignment without costly equipment. So that is how you do cost saving. At the same time, you are achieving value for money and then a durable structure. Curing concrete and ensuring strength. You have to keep concrete moist for at least 7 days to achieve maximum strength. Different, of course, this concrete, we have different. If you have a structural component, structural element, you have a non-structural element, you have a bridge, a building sensitive. They do have different minimum period you need to rigid pavements. They have minimum period you need to attain for you to be comfortable that it can now carry some loads. But at least by default, minimum of 7 days is okay to achieve maximum strength. Use wet bulb, plastic seeds, or curing compounds. I've seen for level areas like floor, people do sand. You pour sand on then you soak it in water. Now that one takes some time because for water to evaporate, which then after some time, like every day, you just keep adding water. You can also make use of gunny bags I've seen people do it. So you do curing like morning hours around maybe by 10, by midday, by 2, by 4, and by 6, maybe. Depending on the weather, you can control the frequency of curing. Very important. If you don't cure concrete, then definitely you're not going to achieve what is required. The design strength, you will not get it. Managing site activities and workers, you have to assign specific roles to workers based on expertise. Now, we have different trades on site. You have the casual laborers, you have the guys dealing with masonry, mason works, there are those who are handling carpentry works, there are those who are handling steel bending, there are those who are handling concrete works. So definitely the assignment and all these activities have their heads, or what we call the foremen. So foremen have a foreman, a carpenter in charge of a foreman in charge of carpentry works. Then you have a foreman in charge of steel bending. You have a foreman in charge of masonry. Therefore, when you're assigning these roles, then you have to assign them correctly. And these are the people that normally you follow. If there are meetings and anything you need to have corrected or implemented, then the respective heads will definitely be of use. Quality controls, deployment, preparing payrolls to pay workers at the end of the week or monthly will be the role of the different heads here, or the different foremen. Then the use of safety protocol, the safety procedure, safety rules, very, very important. For any successful implementation, you have to manage safety, stakeholder safety, and issues to do with risks. So safety is important. You have to make sure and there are these PPEs, personal protective equipment. We have to really make use of it on site to make sure our workers remain safe. If one gets injured, then you will see that the site activity will definitely stop until things are put in place, and that will affect cost and time. Quality control and regular inspection. One of the success stories on all sites is always quality control. You have to do. I know quality control, we always relate it to test. Even here you'll find conduct strength tests, cube tests for concrete. You also do inspect reinforcement, formwork, and curing processes. You have to ensure compliance with structural drawings. So many things. Even the supervision that we do is under quality control. Special attention to other areas is also quality control. So it's not only related to material testing that you talked about quality control. Everything we do on site to ensure what we are working on is done well. That monitoring is also a process of quality control. So we need to be mindful, and that is the only way we can emphasize and be confident that most sites will not have this sudden collapse, because every stage of an activity will have had proper control and then also observance of compliance. Inspection and quality control. Inspection, we talked about these foremen, the different foremen on site. Their role is actually to do that supervision, overall oversight, and then you also have the different leaders within members that you also assign to oversee activities when you are not there as a foreman. These foremen also work under what we call the general foreman. The general foreman is now the one that supervises almost all the activities on site. So these are the foremen in charge of form work, steel bending, carpentry work. They all report to the general foreman. the general foreman reports to the site engineer or the site agent, whoever is in charge of the site. Yep. So it is important. Now, need for industry collaboration. To ensure safe and standardized construction practices, there must be strong collaboration between industry controllers, regulators, and policymakers who enforce building codes. Today in Uganda, we have the different municipal, we have the environmental people, we have the ERB, we have UIPE, the architects, we have so many legal framework in place, and also the regulators that do even ministries like Ministry of Works and Ministry of Works also handle that. So how do we ensure that these codes are being used? So enforcement is important. So industry controllers need to play their part. We need investors, developers, and financiers who fund construction projects need to be aware, need to be brought on board. They need to know what is happening. So for a particular project site, the investor and the industry controllers, they have to be part of the whole process so that they buy in and they know what is happening. Universities and colleges, institutions producing engineers, architects, and technocrats are important. They need also to get exposed to the industry early enough to understand what is required so that they are able to relate their theory to the practical world. So in that way, we are able to control any premature failing of said activity, and we have a bit of unified implementation strategy to ensure that we have a safe construction site. On the job trained professionals, skilled workers dominating the construction industry, we have to make sure there's collaboration. So collaboration is important to ensure that the industry is safe and then rampant collapse of buildings is minimized. We need controllers, we need investors, we need universities, we need on-the-job training to be having some kind of stakeholder engagement with some champions coming maybe from our UI. This is now where UIP and ERB and the architects groups to take the lead and try to champion to ensure that we get to know the minimum do's and the don'ts so that the site practitioners are aware and we avoid any challenge that comes with a lot of fatalities and loss of life. Unified approach and implementation standard establish a common voice among stakeholders to ensure safe and manageable construction sites. Already I've already talked about that. Develop standardized training programs for both academic graduates and on-the-job training. This is what we talk about. We have to collaborate, we have to have some MOUs, we have to have one voice, one common player in the industry to coordinate, to make sure things work out in a manner that everyone appreciates and with a common goal of avoiding fatalities on site. These are very simple things that we do that should be looked at with a bit of interest so that our young people do work which will last for the design life. So it is important that we bring everybody on board as early as possible. So how do you do that? I think this case, since I'm sharing this knowledge, I think the National Review Building Board, I think Timothy and his team, the UIP people, the ERB people, the architects institution people need to find a way to common ground and bring everyone on board, because this industry we have basically, someone mentioned it, that this 70% is being controlled by semi-skilled or unskilled. Even the contractors, some of them don't have engineers with design knowledge, engineers with construction knowledge, engineers with quantity knowledge. So if we can work as a team in the industry, then you are able to make sure the issue of quality control measures. Then this is what I was talking about up there. Mixing concrete. What do you use for mixing concrete? How do you store material? The order of mixing. How do you compact? What about the reinforcement? What about the design, the construction? Okay, for the design, we assume that the engineer will do his part, but the details. How do you transfer the detail from the drawings on ground? This beam reinforcement, the cover requirement, the horizontal and the vertical placement of reinforcement in the beam and slabs. Are they within areas specified by the designer? So, but of course that need to be, that's now supervision, which we talked about, quality control, deliberation on site. So these are some of the things that must be made available to those who do inspection of buildings from the different municipalities and even the city authorities. Joint research and innovation between universities and industry players. That's why it is very important to start introducing the universities to the practical world as early as possible. Industrial training, the research they do at the university must be exactly reflecting or picked from project sites. So these developers can also try to support the university so that at the end of the project, when they are now handing over those as-built information, or there are also some report from those who have done the research and a bit of innovations. It is very important. Or if there are collapsing buildings, we should make sure the university pick up those collapsing buildings and they do a research to come up with comprehensive outputs, and that will fit into lessons learned with the do's and the don'ts that cannot be repeated on another site. So it is important that this is looked at. With all this, if we analyze it carefully, then I think there will be limited or no sudden collapse of buildings or out of plan buildings, which makes the owner frustrated. You have lost money, you start reinforcing a building, but it is not reinforceable. You try to put your infill, the infills are all collapsing. So we need some standardized training, which in collaboration with these industry players, investors, the universities, the on-the-job trained, they need to be aware. So it is very important that some of the things are done, and all this will be done to limit the frequent collapse that we are witnessing. Now, recommended literature here, I think for deeper understanding, we can refer to Materials of Properties by N.K. Jackson. Covers properties of construction materials, even concrete mix ratios and the rest. Mixed design, they're all here. Construction Technology by Roy Chutley and Willie, a practical guide to modern construction technique. We have Standard Method of Measurement, essential for quantity surveying. We have Builder's Guide for Beginners, simplified construction principle for new builders. We have Handbook on Good Building, Design and Construction. So these are some of the literature that our youngsters can read and follow these industry practices to ensure we limit the collapse of building or abandoning building because the building have been condemned before even taking over. So by following these guidelines, site assessments and material checks, builders can prevent structural failures and ensure safe, long-lasting buildings in the industry and in our country. So I think it is of interest that the regulatory bodies in the industry take a lead to bring everybody on board and then do a bit of stakeholder management, engagement. We do some lessons learned from the previous collapse and try to put things right to avoid any collapse of buildings in the country, and specific in Kampala and Jinja area, which have registered quite number. In that way, we shall also avoid loss. And we shall encourage young people to love this industry practices. Structural engineering is very important, it's very interesting, and as we encourage young people to follow it keenly and enjoy. So with that, ladies and gentlemen, this is a quick, simple guideline I generated, which I think I'm going to put it on. I will also load it somewhere as an article for those who can have access, the academia and other places, they can read through. But we shall keep updating and refining and fine-tuning so that it is easily usable by the practicing experts on site. Thank you so much. I hope you will enjoy.